Hello everyone, welcome to part 2 of this lecture. We are going to talk about grouping objects. When we are talking about grouping objects, we are talking about collection, and this will also include loop. You might have heard about loop in other programming languages. Basically, loop can be used to execute a block of a statement repeatedly without having to write them multiple times. So for example, let's say I want to write a program that find out if students who are less than 50 will fail and students who got greater than 50% will pass. So rather than, and I have 20 students in my class, rather than writing this statement, if a statement 20 times to see if this student is greater than 50 will pass, if it's less will fail, rather than writing that, I'm going to write a statement, a for loop statement, or for each loop statement, or a while loop statement. And rather than repeating it, I will just have to write it once. And that will actually help me because it's going to save time and I'm going to make less mistakes. And that's what the programmer does. They use these loop statement for these type of purposes. So basically, Java has two kinds of for loop. One of them that we will discuss in this book more is the for each loop. And the other one is basically a simple for loop. So right now in this chapter we are going to talk about for each loop, and in other chapters, I think maybe chapter 7 or 8, I'm not remembering it correctly, we will discuss the for loop. So they are different, they are not the same. I mean, the structure of it is different, maybe the concept is the same but the structure is different, and so your syntax, everything will be different as well. So one of the things that I want to mention is for the iteration. Using the for each loop, it basically help us repeat each item in the collection that we have. And the iteration will stop when we reach the end of the collection. For each loop, it provides basically definite iteration. So basically we have to kind of know where it will stop. So the loop body will be executed the number of times that exactly matches the size of that collection. But there are a lot of situations that we might not even know how many times we have to repeat the same action. So, and we cannot predict exactly how many times that could be. So a for each loop doesn't help in that time. So just remember that for each loop, it will repeat until the size of the collections. As I have said, we will have other loops, loops that such as while loop and the for loop, which we can talk more about it later. But for now, we will just focus on for each loop. And just remember again, for each loop and for loop are different. So as we said, we often want to repeat some action over and over again. Loop provides us with the way to control how many times we can repeat these actions. And with the collection, we often want to repeat things once for every object in that particular collection that we have. Let's look at the for each statement and the syntax for it. So basically, we can say that we are going to use the for here. That's the keyword that we are looking for. We have the element type, element, column, collection. This is the loop header. So this is just the general structure for how we are going to actually write the for loop. And then open parentheses, you will have the loop body. So this is the statement that is going to be repeated. So that's basically for each element in collection, you do the things in the body of the loop. So that's basically a standard that we are going to use for each loop. So let's just go again and read this. So how do we read this? We are going to say for each element in the collection. So for each element in our collection, we do these things that are in the loop body. So that's how we read the for each statement. So let's look at the example here. In this example, it shows the implementation of list all files method that basically lists all the file names currently in the organizer array list that use the for each loop statement. So for each file name in the file, you print out the file. So let's say that you have basically your 4 strings in the list. The print statement will be executed 4 times. So if we remember the array list that we have talked about, each time before the statement is going to be executed, the variable file name is set to hold one of the list elements. First the one at index 0, then the one at index 1, then the one at index 2, and so on. Each element in the list then gets printed. If it holds 4, it will be executed 4 times. So let's summarize this. Loop statement allow a block of a statement to be repeated. The for each loop allow iteration over a whole collection. And of course we said we have 3 different kind of loop: for loop, for each loop, and while loop, which we are going to discuss in this chapter, the for each loop right now, and then for loop will be discussed in other chapters. Now let's look at selective processing. So we are in here, what we are doing is kind of the similar thing, but we are adding more filter to it. We are making it a little bit more complex, making it more selective. So it's the same thing. We are going to use the for loop. It's going to look at the files, and it's going to find that file name that contains search string. So it's actually going to pass the string, the name of the string. Let's say like in our collection we want to find the sounds for Madonna, or I don't know, another artist that you like. So the search string would be the name Madonna, and so it's going to go through the for loop, and it's going to go find those files that has the word Madonna in it, and it's going to print only those songs that has the string name that has the Madonna in it. So it will actually passes the string, and you will become, so your selection would be more selective. So you're not going to get the entire file. You're going to get those that has the string Madonna in it. Some of the critique for each: it's easy to write. The termination happens naturally, because remember, this is it goes through the iteration stops when we actually reach the end of the collection. So a for each loop provides definite iteration. So given the state of particular collection, the loop body will be executed the number of times that exactly matches the size of the collection. That's very important. There is no index provided. So basically, if you want to, not all collections are index based. So if there's no index, then that's another problem with the for loop, because it can continue, it can keep going, and once it's the start, it cannot be stopped. So we cannot stop partway through it. It's better to use other loops. And it, as we said, it provides definite iteration, and it will go through the whole collection. So if there are situations where we want to repeat some action, but we cannot predict in advance exactly how many times that could be, this type of loop is not going to be useful. So we will suggest you to use the for loop or the while loop. So, and we will discuss the while loop shortly. So if you don't know exactly how many times we want to repeat the same action, it's indefinite iteration. So we will use the while loop. So that's why there are other loops that you can use. You don't have to use the for each loop all the time. There are a lot of programmers actually prefer the while loop or the for loop more because of this reason. So in indefinite iteration, the search action will repeat an unpredictable number of times until the task is completed. So this is very common in the programming situation. So we are not exactly know always what we are looking for, and we don't know where we have to stop. So in this type of situation, we will be using the while loop. So we cannot predict in advance how many places we have to look, although there may be well an absolute limit, such as checking every possible location that could be possible. And so in this situation, which we want to keep doing something until the repetition is no longer necessary, are frequently being encountered in the programming language. And indefinite loops are also possible through error or the other type of task. You could have indefinite loops. As we said, a for each loop repeats the loop body for each object in a collection. Sometimes we would like more variation than this, so we use a Boolean condition to decide whether or not to keep it going. A while loop provides that type of control for us. So let's look at the while loop pseudocode. So of course, same as for each loop, so the keyword here would be the while, and then you will have the Boolean test, and then you will have the loop body, the statement that could be repeated. So basically, you will have this condition here, the Boolean test here, after the while, and then you would repeat this. So while we wish to continue, do the things in the loop body. So that's how we are writing the pseudocode for the while loop. So let's go through this example. Basically, let's say we actually lost our key and we want to write a program with that to be able to find our key. So in the logic will be that when we arrive at the loop for the first time, the condition is going to be evaluated. The key are missing. That means we enter the body of the loop. So this is the key are missing. Okay, we are gonna look in the next place that we have in our mind. Then we will return to the condition again and re-evaluate it. If the key is found, okay, great. The loop is going to be finished and we can skip over the loop and just basically forget about it. If the keys are still missing, then we can go back again in the loop and look for the next place. So this is going to be a repetitive process until we found the key. So until the key is not missing anymore. We could also write this here like this. While not the keys have been found, look in the next place. So it's kind of the logic of these two is similar. Both of them are equally valid and reflect the choices of expressions. So we will have to basically think about our logic before we want to actually write the pseudocode. So in both cases, what we write inside the loop when the keys are finally found will mean the loop condition flipped from true to false the next time they are being evaluated. So basically, you just have to think about the logic and think about how you're going to write it. So in this case, you could write it like this, or you can write it like this, as long as it makes sense in your head. So for a lot of programming coding, we first have to write the pseudocode, the logic behind it, and then we look at the syntax. Okay, then we look at what type of loop we can use and so on. So in here, if we look at the while loop, what do we think? If we don't find them, then in this scenario, it keeps going. So that's what the while loop does. It keeps going until the condition gets satisfied. So it here is search, if the condition is true, it's first searching. If it's true, the while searching, if they are found, then that's it, it will stop. If they are in the next place, you keep searching and it will continue. So until the condition is satisfied. In here, we are actually iterating with an index variable. So first, we have to declare a variable for the list index, and we have to initialize it to 0 for the first list of elements. Then the variable must be declared outside of the loop. Then we are going to use our loop. We have to basically express the loop condition in order to making sure that the loop stops at the right time. And then the list of elements, they are not going to automatically be fetched. We have to use the get method of the array list. The variable that we have used, the file name, will be local to the body of the loop, and it will print that file name. We have to remember to increment the counter variable index. The last statement that you have here is basically showing a special operator for incrementing a numerical value by 1. So in here, index plus plus means you are incrementing the index by 1. You can also write index equals index plus 1. So that's what this means. So as we said, we have basically declared an index variable. The condition must be correctly expressed, and then we have to use the get here to fetch each statement, and then the index variable must be incremented explicitly, which we use the index plus plus at the end of that loop. So basically, if we want to look at the page 152, it will explain to you the differences between the for each versus while. So basically, some things that you can just get from here is easier to write the for each statement. It's safer, it's guaranteed that it will stop. While we don't have to process the whole collection, it doesn't even have to be used with a collection. Something that we have to think about, that the loop can go on and on and on, so we need to make sure that we put a condition. So it could be an indefinite loop. So that's the main difference. In a lot of programming, we use this a lot, the while loop and for loop, not for each loop, but while loop and for loop a lot. Some of the things that we have to think about searching is one of the most important form of iteration. Basically, some of the things that we want to think about, some of the essential elements, is basically it's applicable beyond collections. The necessity is indefinite, and we must code for both success and failure. Both must make the loop condition false, and the collection might be empty as well. So there are ways that we can actually finish the search. Either there are no more items to check, index is greater than equal file size. Always remember that the index is smaller than file size. It's always less than the file size. So if that is the condition, then the search will be finished. Or if the item hasn't been found. So if the found is equal to true, it will be the item is found, and this exclamation mark means we are not searching anymore. So we can actually end the search.